4 humans are about to become the first people in half a century to ride a rocket powerful enough to throw them beyond Earth's gravity well and sling them around the moon at nearly 40,000 kilometers per hour, and then come home without ever landing there. That is Artemis 2. On paper, it's just a 10-day test flight. No lunar module, no boots on the surface, no flags or footprints. But in engineering terms, Artemis 2 is the dress rehearsal where NASA proves that the entire deep space transport system works with real human lives on board. It's the moment when a stack of hardware and software, the Space Launch System rocket, the Orion spacecraft, and a global network of tracking and life support systems has to operate as a single, coherent organism. To see where Artemis 2 fits, zoom out to the bigger program. The Artemis architecture is a sequence. Artemis 1 was the uncrewed shakedown cruise, launched in 2022. It flew Orion around the moon, pushed the capsule and its heat shield to their limits, and brought back terabytes of sensor data without risking astronauts. Artemis 2 is the next escalation. Add a crew, keep the mission relatively simple, but push into deep space. Artemis 3, later, is where a separate lander, built under contract by SpaceX, is planned to ferry astronauts from lunar orbit down to the surface. So Artemis 2 is not the moon landing itself. It's the critical human test of the transportation backbone that makes later landings possible. Let's unpack that backbone. The rocket is the Space Launch System, or SLS, a 2-stage heavy-lift vehicle. Its core stage burns liquid hydrogen and liquid oxygen in 4 RS-25 engines, upgraded versions of the Space Shuttle main engines, producing about 8.8 million newtons of thrust at liftoff. That's in the same league as the Saturn V, the Apollo-era rocket that first took humans to the moon. Strapped to the sides are 2 solid rocket boosters, which provide most of the initial push through the dense lower atmosphere. Sitting at the very top is Orion, the crew vehicle. Think of Orion as the Apollo capsule's great-grandchild. Scaled up, more internal volume, a modern digital cockpit, an advanced life support system that recycles air and water, and a heat shield designed to survive 11 km/s re-entry from lunar distance. Artemis 2's flight profile is deceptively elegant. After launch, SLS places Orion into a temporary parking orbit around Earth. Engineers use this phase to check out all critical systems with the option, in principle, to abort before committing to deep space. Then comes translunar injection. The upper stage fires again, increasing Orion's velocity by roughly 3 km/s, enough to escape Earth orbit on a path toward the moon. Unlike Artemis 3, Artemis 2 is a so-called hybrid free return trajectory. In a pure free return, gravity alone would swing the spacecraft around the moon and send it back to Earth, like a cosmic slingshot, even if the engines never fired again. Artemis 2 modifies this slightly to let Orion test its propulsion system while still preserving a gravity-assisted path that enhances crew safety. The heart of the mission is not the scenery, it's the systems. For the first time, Orion's environmental control and life support system will run in deep space with humans breathing its air. It has to maintain pressure, scrub carbon dioxide with regenerable filters, control humidity so that condensation doesn't short electronics, and regulate temperature in a vacuum where heat can only leave via radiation. The crew will also serve as biological sensors, wearing dosimeters that measure exposure to cosmic rays and solar particles outside Earth's protective magnetosphere. Meanwhile, ground controllers will stress test the communication architecture, high-gain antennas, laser communication experiments on later missions, and the deep space network of radio dishes spread across 3 continents, all coordinating to keep a continuous data link over distances of up to 400,000 kilometers. In spirit, Artemis 2 echoes Apollo 8, the first mission where humans orbited the moon in 1968. But the constraints and goals are different. Apollo raced to beat the Soviet Union with a series of short, high-risk missions. Artemis aims for something slower but more durable. A transport system that can be reused, extended with a small space station in lunar orbit called Gateway, and eventually tied into Mars exploration. In that sense, when the Artemis 2 crew look back at the Earth hanging over the moon's horizon, they won't just be reenacting a historic moment. They'll be validating the machinery intended to turn the moon from a destination into an infrastructure hub. The real complexity begins when this proven lunar transport system has to interact with another spacecraft entirely. the lander that will actually touch down on the moon.